Hello everyone, what's up? In this video we are going to look at the problem C from the Codeforces round 669, which was held 2 days ago on 8th of September. It is the problem is called Chocolate Bunny. It is an interactive problem. So here we have been we need to find out an array of size n. That is, right now all the elements of the array are hidden, and the elements would all be distinct, and the values inside the array or the element present in the array would be from 1 to n, and the size of the array is also n. So we can ask 2 into n queries to find out the elements of the array and their right sequence as well. And to ask queries, we can write out our queries will be of this format, that is question mark x and y. Then that we would be getting element present at index x, mod element present at index y. That is, if we are querying I and j, it will reply with pi mod pj. Okay, and we need to find out the exact sequence. That's all. And others are just simply for the interaction. This is not related to the problem solution. Now let's see what we can do to solve the problem. So we have an array of n elements, and at most we can ask 2 into n queries. Now the thing which we would be using is, for two elements which are present, for two elements a and b, if we take a modulus b, and if we also take b modulus a, then there can be two cases. If this a modulus b is less than b modulus a, or this a modulus b is greater than b modulus a, as the all elements are all distinct, so they can never be same. Okay, so if you see, if this is the case, then we can be sure that yes, in this case we can be sure that a is greater than b, and in this case we can be sure that b is greater than a. And why so? Because if you see that the term present here is greater than b, you will realize that after doing this b modulus a, we can only get the values ranging from 0 to a minus 1, and if we do n modulus b to any number, we will be getting a number or output from 0 to b minus 1. So if a modulus b is lesser than b modulus a, we can say that a is greater than b. We can there is also some proof related to it. I won't be going to the proof, but we can take any example. Suppose we are taking 7 and 9, and if we do 7 modulus 9, it will be 7, and if we are doing 9 modulus 7, it is 2. So as you see, then this term is greater. So this is for the second case. In this, b would be greater than a. Here b is 9, so 9 is greater than 7. And if we are taken the other case, suppose this is 10 and this is 6, here a and b, so a modulus b would be 4 and b modulus a is 6. So in this case it is this one where the second term is larger, so we see a is greater than b, so a is 10. And also if we see here, if this is what we are getting, it means a is greater than b. Also it also means if a is greater than b, then this term right here, which is the lesser one, would be equal to b. Because for example, if we have two numbers b and a, if b is less than a, then if we do b mod a, it would be equal to b. because yeah, you can take any example, because it is not going above the value of a, or it is not going outside the range of 0 modulus a minus 1, so it will simply be b, because b is present in between 0 minus a1. And in the second case, if we see, if a modulus b is greater than b modulus a, it means b is greater than a, and in that case this a modulus b would be equal to a itself. We can take example for this as well. If we take 7 and 11, then a modulus b would be 7 and b modulus a is 4. So yes, yeah, this is this 7 and 11 is for this case. So then in other words, we can simply say, yes, we are finding these two terms. The lesser one would be suppose we are storing the answer of this in result 1 and storing the answer of this in result 2, and the lesser one, the smaller out of result 1 and result 2 would be equal, we can do this thing, minimum of resultant 1 or resultant 2 would be equal to minimum of a over b. So using two queries for any pair, that is for numbers a and b, we can ask for two queries, that is a modulus b and b modulus a, and using these two queries we will be able to find out one element among these two, which is the smaller one out of a and b. So we will be doing this operation for n minus 1 elements. Queries used would be 2 into n minus 1, and to find out the last element, that is the nth one. So during our process, when we were finding these n minus 1 elements, I was also maintaining a variable called sum. Initially it was so yes, as I found the n minus 1 elements, from I will be adding the new element to my sum variable, and at the end I would be sure that this sum would be containing the sum of already found n minus 1 elements. To find out the last element, I will just do the sum of first n natural numbers minus this sum variable, which would be equal to the last element. So in total we would be doing 2 into n minus 1 queries, and at last we will have our sequence. And yes, we are maintaining two pointer approach, that is, we will initialize our pointer from the beginning of array, and second pointer at the last, that is j n minus 1. We process two queries for this element present at ith index and element present at jth index. For two queries, suppose we were able to find the element which was present at ith index, then we will just do I plus plus, then proceed with our solution with these two indexes. Otherwise, suppose if our element which we found had been present at the element j, then we will store its value, decrement j by doing j minus 1, j minus minus, and then do further processing with these two elements. At the end we would be having I equal to j, for that would be the last element, and to find the last element we will be just doing this. Let's see the code now. Yes, first of all, I've taken the input, that the number of elements in our array, then I've initialized these two pointers, sum as 0, then I'm doing these two queries for I and j, as it is one index, so I'm passing my I plus 1 and j plus 1. Yes, I'm storing the result in result 1 and result 2, and then I'm checking if result 2 is lesser than result 1. It simply means the element should be present at the ith one, which is the lesser one, and if it is the other way around, that is result 1 is lesser, it means the element would be present at the index j, and it should be the lesser element, that the element having the lesser value. And at the end, when we break out of this loop, we would be sure that I equal to j, then we will simply find out the last element. After that we would be printing the elements. Okay guys, that's all for this problem. In the next video I'll be coming up with the solution of problem D, so stay tuned, and if you like our videos, then press the like button and do subscribe to our channel. Okay, till then, take care, sayonara.